Hello and welcome back to the show. Hopefully you're enjoying the channel and hopefully you hit that subscribe button. We're going to be talking about the zero product property and how we can use it and apply it to solving quadratic equations. First, a quick review for the zero product property. If the product of two quantities equals 0, at least one of the quantities must equal 0. Or in other words, anything times 0 is 0. So here, when we have a sample with numbers, this must be 0 in order for the product to be true. 9 times 0 is 0. 0 times 4 is 0. This also works algebraically. So if A times B is equal to 0, then A must equal 0 or B must equal 0. This is what we're going to use to solve our functions. So let's look at the equation x minus 3 times the quantity x plus 8 equals 0. First, we're going to let A equal x minus 3 and B equal x plus 8. Since A times B is 0, we know that A must equal 0 or B must equal 0. Therefore, x minus 3 must equal 0 or x plus 8 equals 0. So we're going to go ahead and solve for x. Here, when we have x minus 3 equals 0, we have to add 3. So we get that x equals 3. Here, we subtract 8. So we get that x equals negative 8. So the solutions of your equation are x equals 3 and x equals negative 8. If you remember back to our previous video on connecting intercepts and zeros and linear factors, we know that the solutions of the equation are the zeros of the related function. Since we have x minus 3 times the quantity x plus 8 equals 0, we have this function f of x equals x minus 3 times the quantity x plus 8 because they satisfy the equation f of x equals 0. So therefore, the solutions of the related function x minus 3 times the quantity x plus 8 are x equals 3 and x equals negative 8. If you took a moment to graph these on your graphing calculator, you would see that your y-intercepts are in fact 3 and negative 8. Go ahead and take a minute to do that for yourself. Okay, I'll show you on my table that I put in here the equation x minus 3, x plus 8. When I go to my table at negative 8, I have 0. No, it's a little hard to see, I apologize for that. And at 3, y is 0. All right, to continue. When we look at the problems on the back, we're going to be using the zero product property to solve and find the zeros of the functions. So we're going to set each factor to 0 and then solve for x. First example is done for you. Let's look at the second one. So we have our function f of x equals the quantity x plus 1 times the quantity x plus 23. First, we're going to set that equal to 0. And then each factor must be 0. So when we solve, we get our factors. Therefore, the zeros are negative 1 and negative 23. So if we look at this discussion, it says that Jordy was asked to identify the zeros of the function f of x equals the quantity x minus 5 times the quantity x plus 3. Her answers were x equals negative 5 and x equals 3. Do you agree or disagree? So I disagree because those are the values she sees, not their opposites. We want their opposites so the sum is 0. So I'm going to disagree and state that x equals 5 and x equals -3 are the zeros. Right? We want 0 pairs. How would you find the zeros of the function f of x equals the opposite of 4 times the quantity x minus 8? I'm going to set it equal to 0. And then solve for x. If we do that, we get -4 times the quantity x minus 8 equals 0. I can divide by -4. I get that x minus 8 equals 0. I add 8. I get x equals 8. Okay, zeros of the function f of x equals x times the quantity x minus 12. So here it might look like I only have 1, but I do still need to separate this. So in fact, I do get x equals 0 as a value, and x equals 12. So you have to be careful when the first one is a monomial and not a binomial. So now we have to find the zeros. So x minus 10 equals 0, x minus 6 equals 0. Solve for x. Okay. And here, right, so we set this equal to 0. The 7, because it's a 7 on the outside, it has no impact on our zeros, so we can ignore it when finding our zeros. And again, you can always check these by putting the equations into a graphing calculator and finding the zeros. I hope you found the video helpful. Please ask any questions that you might have in the comments below, and have a wonderful day.